Okay, so today we're going to do Unit 2, Day 13 notes, which is qualitative graphs. Now, qualitative graphs are graphs used to represent situations that do not necessarily have a have numerical forms. Okay? Now, example 1. The graph below displays the distance from Lewis's home as he walks his dog in his neighborhood. Describe the change in the distance from his home over time. So if you notice, if you see part of the graph going up, you know that means increasing. This part, when it's flat, will be constant. That means stop in this situation. This, of course, means increasing. And then the going down part means decreasing. So basically, here, he's increasing the distance from his house, so he's walking further away from the house. Here, he has stopped in his location, so he's not moving further away from the house. And once again, he starts walking further away from the house, so he's increasing the distance from the home. And then here, he's going back to his home. So the distance between the home and him is decreasing. Okay. Now, for the next one, it says the graph below displays the speed of a city bus as it stops frequently to pick up passengers. Now, I'm only going to focus on the first part of the graph because after that, it will repeat. And because it's really small, I won't have that much space to constantly be writing over and over the same information. So here it's increasing. So we're talking about speed. So he's increasing. The bus driver is increasing the speed. Then the speed becomes constant. Then he slows down. So the speed is decreasing. And then right here, he stops. Okay, so he's driving, his speed is increasing, and then he's at a constant speed, and then he slows down, then stops, and of course he increased the speed. His speed is constant, then the speed starts to decrease, then he stops again for a little while to pick up passengers, then he moves and his speed is increasing. Once he reaches that speed, he stays constant, and then he slows down again and stops to pick up another passenger. So as you can tell, it's increasing, speed is constant, it decreases, and then it stops, and then the pattern repeats. Okay? So let's try an example. Number 1, a train pulls into a station and lets off passengers. So what happens when the train arrives? The train has to slow down. Okay, so that means the speed is decreasing. Okay, that's what we're saying, that it's decreasing. So now, we're looking for the graph that represents that. Well, obviously, this means constant. The speed is constant. So that's not what we're looking for. We're looking for the one that shows decreasing. Obviously, the answer will be B because you can tell that this is decreasing. The speed is going down until it stops. And so the answer is B. Well, what about C? This little part right here says increasing. This part right there says decreasing, increasing, decreasing, increasing, decreasing. Okay? Now here, this says that your speed is constant, and then boom, stop. Okay? Well, not necessarily stop, but it means that your speed decreases quickly. So you're going at a constant speed and then the train stops. just completely stops. And that's not what we said. We said that the train is slowing down, so it's decreasing. So the only one that shows a decreasing at a fair rate will be B. Now, number 3, a woman climbs a hill at a steady pace. Okay, so that means that the speed is constant. Okay, and then she starts to run down one side. So what happens when you're running down a hill? Your speed increases. So then it's increasing. So we're looking for the one that shows that it's constant and then increases. Okay, so you're constant, then increases the speed. So the only one that makes sense will be A, because if you notice, this is constant speed, then increases. Over here, you're increasing, and then decreasing. Here, you're increasing, and then constant. And then, of course, you're increasing, decreasing, increasing. Okay? So the one that will make more sense will be BA. A woman is climbing a hill at a steady pace, steady rate, and then she starts to run, she starts to run down one hill, which means her speed is increasing. So the answer will be A. Now, number 4. Which scenario best describes the graph below? When you have problems like this, I would automatically put down what the graph is showing. So the first part of this graph is increasing. And as you can tell, you're increasing quickly. And then the next part, you are increasing but at a slower pace. And then the last part, of course, you can tell it's constant. Okay? So let's look at the situation. Which situation best describes something that's increasing quickly and then increasing at a slower pace, and then it's constant? As the weight of a package increased, the shipping costs increased proportionally. That's not right, because proportionally means that they were increasing at the same pace. That's incorrect. And plus, it didn't say anything about it being constant, so that's out. A race car driver accelerated quickly, okay? Stopped, we didn't say anything about stopping, so that's out. A vacuum salesperson sold a constant number of vacuums and then experienced a steady increase in the number of vacuums sold. Once again, it doesn't say anything about increasing quickly, and the constant is off, so it's not C. D, a puppy gained weight quickly, okay, increasing quickly. Still gain weight, but not as quickly, increasing at a slower pace, okay, check, check. And then stayed at a constant weight, constant. D, that's the one that represents the 3 parts that I'm looking for, okay. Now, number 5, the graph below shows a relationship between 2 variables. Well, with problems like this, I would like to name out the different parts. So start here. That means it's increasing. Then I'm decreasing. And then increasing quickly. Almost faster than the first time. Okay, because you see, this line is slowly increasing, decreases, and then we quickly increase again. Okay, so let's see which one has that. David drove at a constant speed. Nope, does not have, because he needs to be increasing his speed. The number of perfect test scores by students in a math class increased from first to the second grade period and began to decline. Okay, that's not right either. After a period of slow growth, the height of a plant remained the same for 2 weeks. Nope, that means constant. There's nothing about constant. The number of employees at a store increased at a constant rate for 5 years. Then there was a decrease in the number of employees for 2 years. Then the number of employees increased at a greater constant rate for the next few years. That one's the one that makes more sense because you're slowly increasing for 5 years, then the number of employees goes down for 2 years, and then it increases quickly for the next few years. So the best option will be D. Okay? Of course, if you have any questions, please do not hesitate to ask me in class tomorrow.